All right, derivative taking is such a blast. We are going to take some higher order derivatives today. So it says find the first and all higher derivatives of that polynomial. Well, you know how to find the first derivative. P prime, you're doing the simple power rule. So you are just rocking through each of those. Negative 8x cubed plus 27x squared minus 10x. So that's the first derivative. Now it says all higher derivatives, which means, well, if the first derivative was that much fun, let's just take the second derivative. Let's take p double prime of x, which is the derivative of the derivative. The derivative of the derivative. So I just do power rule again. I'm just looking at now this derivative, the first derivative, and taking the derivative of him. So negative 24 x squared plus 54x minus 10. And then you think, well, let's just keep having the fun. Now you take the derivatives that you can do. Third derivative, negative 48x plus 54. The fourth derivative, usually after 3, they end up writing the number. I do that. I don't do a Roman numeral of 4. I do p of 4. It kind of looks like that, of x. Would be negative 48. And then I kind of ran out of space, so I'll do it over here. The fifth derivative would be 0. Now I could keep going. The sixth derivative would be 0, 0, 0, 0, 0. So, but notice that I do get down to the derivative of 0. Wouldn't that be true for all polynomials? If I gave you any polynomial, wouldn't it be true that eventually I would get down to a derivative of 0? And notice if I ask you, well, what power? If I gave you, something like f of x was, 2x to the 57th plus 5x or whatever. Which is the first derivative that would give you 0? And hopefully you see the relationship. Notice this had a degree of 4. My fifth derivative was equal to 0. So if my degree is 57, the 58th derivative would be the first one to be 0. So that's just kind of a good thing to know. Now let's do some trig. Trig ones won't necessarily go down to 0. So if I have cosine and sine, I'm not going to go down to 0, but I think you could try to find the first and second derivatives there. And remember that little helpful thing with the sine and cosine. If you wanted to draw that, that might help you out. So let me remind you of that. Remember, if this is positive cosine, positive sine, negative cosine, and negative sine. And remember, derivatives go in clockwise. So if that kind of keeps it straight in your brain, if that helps you, then cool. So the first derivative, and luckily, do I have to do the product rule on this one? Hopefully you say no, because I don't. With each term, there aren't two x's, so that constant can just kind of rock along. So the first derivative is going to be negative 4 sine of x. The derivative of sine is cosine. Now take the derivative of that. So the second derivative is going to be negative 4 cosine of x and minus sine. Now look at the next question, and I will tell you there was a similar question to this one on the AP exam last year. I think, according to Twitter, because it was talking about finding some 26th derivative or something like that. And so it had to be a sine and cosine one because, or a polynomial. But here's the funny thing. You're like, seriously? I have to go, whether they asked me the 26th, but man, I was mean. I asked you for the 97th. You're telling me I have to find 97 derivatives? Like, are you kidding? Well, let's look at that. Now, notice this is a continuation in a sense, so I'm not going to write the first and second derivatives again because I've already done that. And you go, okay, I'm not seeing it. Well, let's continue on. Let's continue on. Why don't you take the third derivative? So we have the first derivative here, the second derivative here, and now let's find the third derivative. That third derivative would be 4 sine of x minus cosine of x. I'm still not seeing anything yet, so I'm like, all right, let's take the fourth derivative. And that derivative would be 4 cosine of x plus sine of x. And then you go, wait a minute. Look at this fourth derivative and the original question. Here, I'm going to circle it up here just because it's above the first derivative. But do you notice that those are the same? So wouldn't it be true if I said, okay, if the fourth derivative is this, wouldn't this be the fifth derivative, sixth derivative, seventh derivative, and eighth, ninth, 10th, 11th, 12th? Now you go, oh my gosh, I'm going to count to 97. No, I'm not going to do that, but I'm just showing you those numbers to say, all I have to figure out is if I divide the number by 4 and it goes in evenly, this is going to be my derivative. These have a remainder of 1, these have a remainder of 2, these have a remainder of 3. So let me just see how many times 4 goes into 97 and what my remainder is. I don't care how many times it goes in there. That is irrelevant, but 8, and then I'd have 17, so I'd go in 4, 16. The key is this number. What is my remainder? My remainder is 1. So the 97th derivative is going to be the same as this, the first derivative. So this is like remainder of 1, 2, 3, and this one is if it goes in evenly. So the 97th derivative is going to be negative 4 sine of x plus cosine of x. So if you see a really high derivative, you better believe there's some pattern to it. Find the derivatives, keep finding derivatives until you see the pattern, and then go. There's no way on an AP test they're going to ask you for this 97th derivative, and you have to get it by finding all 97 or even 20-something. There's going to be some pattern. All right. Let's look at velocity and position. And again, you physics people will be like, oh, we've been doing this for a while. If I have a position function of an object, the rate of change of position with respect to time is velocity. Well, that should make sense. You know, if you're talking about your distance from your house, well, the rate of change of that distance is like miles per hour. So it's the distance, change in distance over time. So the rate of change of position is velocity. And then the rate of change of velocity with respect to time is acceleration. So you have to realize that it kind of goes in that order. Is that you have the position equation, its derivative is velocity, and its derivative is acceleration. So as I'm going down, I'm differentiating or taking the derivative.